Throughout most of history, the word scientist did not exist in the English language, nor was there any other word that conveyed a similar meaning. Even Sir Isaac Newton was never called a scientist during his lifetime, but instead called a natural philosopher, because the word scientist did not yet exist when Newton died in 1727. The word scientist in the English language was coined in 1834 by William Whewell. William Whewell is the same person who coined the word physicist in 1840. Despite their many successful contributions to science, William Whewell and Isaac Newton also each developed ideas that we today consider to be highly unscientific. From the beginning, there was considerable debate about how scientists should be different from philosophers, and about what steps should be included in what we now call the scientific method. The answers to these questions developed gradually over time. There were many various opinions, and there is still debate today. For example, quantum physics allows us to make incredibly accurate statistical predictions, but fails to give a philosophically satisfactory answer to what is actually happening. And many people now argue that this is not the job of science, as will be discussed later in this video. One key difference between the scientific method and the approach of many ancient philosophers is that science is based on observations. Many ancient philosophers believed that we should avoid basing knowledge on observations because our senses often deceive us, and even the most sophisticated measuring instruments can give erroneous results. They argued that the only true knowledge we can know with certainty is that which we can deduce rationally without any observation, such as the laws of Euclidean geometry. The problem with this argument is that in the 20th century, we discovered that the laws of Euclidean geometry actually do not describe the universe we live in, as has been demonstrated by experimental observations testing Albert Einstein's general theory of relativity. This demonstrates that even that which we think we know with absolute certainty, based entirely on rational deduction, might be proven wrong when compared to observations. We can only make a guess about how the world works, which we call a hypothesis, and then compare the predictions of this hypothesis with the actual experimental results. No matter how much experimental evidence we accumulate in support of our hypothesis, it's always still possible that the next experimental observation might prove all our ideas wrong, and we will have to start over. No answer is ever final. This, too, is very different from the way philosophy was often handled prior to the scientific method. For example, the philosopher Aristotle was so highly respected that many scholars would continue to insist that Aristotle's teachings can't possibly be wrong, even if contrary observational evidence was presented right in front of their own eyes. As a result, the teachings of Aristotle severely hindered the development of science for almost 2,000 years. The scientific method requires open debate, and if people are not allowed to challenge the accepted authorities, then this is no longer science. Of course, this is not a new idea. For example, Alhazen, who lived from 965 to 1040, argued that we need to be highly skeptical of Aristotle and other authorities. Alhazen is quoted as saying, "If learning the truth is the scientist's goal, then he must make himself the enemy of all that he reads." He argued that a hypothesis must be supported by experiments based on confirmable procedures or mathematics, and he made many great scientific discoveries based on these principles. Individuals such as Alhazen have vigorously advocated and practiced all the ideals of what we now call the scientific method, centuries before the scientific revolution. Unfortunately, in the years following the scientific revolution, there are many times when the scientific community has failed to live up to the ideals of the scientific method. This point was articulated in 1962 in Thomas Kuhn's book, The Structure of Scientific Revolutions, focusing on the history of how science has actually been practiced by actual scientists. Kuhn pointed out that the scientific community often develops a set of broad basic assumptions, called a paradigm, which scientists are reluctant to admit is wrong, even when observational data contradicts it. Scientists conduct research and evaluate the validity of all new ideas within the context of this paradigm, and are unlikely to seriously consider anything which contradicts the paradigm. But the scientific community does eventually change its mind, moving from one paradigm to another, in a process that Kuhn called a paradigm shift. Therefore, Thomas Kuhn believed that the scientific community still makes progress over time and heads in the right direction in the long run. Thomas Kuhn lived from 1922 to 1996, and his ideas about paradigm shifts were highly influential in the philosophy of science. Another person whose ideas were highly influential in the philosophy of science is Karl Popper, who lived from 1902 to 1994. Karl Popper proposed a demarcation line between science and pseudoscience, which has now been adopted by many people. To explain this idea, hypothetically suppose we see objects moving in front of us. Hypothetically suppose we propose the hypothesis that there is an invisible demon moving the objects. Is this a scientific hypothesis? Why or why not? Some people would argue that a valid scientific hypothesis can't involve the supernatural, or that a good scientific hypothesis should try to have as few arbitrary assumptions as possible. Other people would argue that there is no official rule in the scientific method stipulating these requirements, and that any hypothesis is valid, provided that it can be tested experimentally. Suppose we test our demon hypothesis by placing various objects in the room. If one or more of the objects move by any amount, this is in agreement with our hypothesis because we say that the demon chose to move those objects. If none of the objects move, this is also in agreement with our hypothesis because we say that the demon chose not to move any of the objects. Notice that for this hypothesis, regardless of any possible outcome of our experimental observations, we can never conclude that our hypothesis is wrong. In other words, this hypothesis is unfalsifiable. By contrast, an example of a falsifiable hypothesis is Newton's law of gravity. If we were to let go of a brick and it hypothetically fell upwards, then this could prove that Newton's theory is false. An advocate of Newton's hypothesis is prepared to conclude that their hypothesis is false if certain predictions fail to be observed. By contrast, an advocate of the demon hypothesis is never prepared to conclude that their hypothesis is false, regardless of any possible observations. Many people would argue that this is the real reason why the demon hypothesis is unscientific, and not because of prejudice against the possible existence of demons. That is, Many people would argue that the demarcation line between science and pseudoscience is falsifiability. And this is what Karl Popper proposed. There is debate about the validity of this proposal, and there is also debate on how to apply it. For example, some people insist that certain social sciences are not really science because they don't make falsifiable predictions in the way that physics and chemistry do. Many people also argue that in the case of many pseudosciences, we actually have considerable observational evidence contrary to what these theories predict. Though this is a contradiction. We can't simultaneously claim that a theory is unscientific because it is unfalsifiable, while at the same time claiming that the theory has, in fact, been falsified. Arguably, if a theory has been proven false with observation, then this means that this was, in fact, a scientific theory. Just a bad one. Also, there is a debate about the very nature of science and its ability to describe reality. For example, as mentioned earlier, quantum physics gives us mathematical models which make incredibly accurate statistical predictions, but fail to explain what is actually happening. There are many different philosophical interpretations of quantum mechanics, with radically different descriptions of the world. But many of these interpretations give identical statistical predictions for all possible observable data. If multiple theories make all the same observable predictions, then how do we decide which theory is the more accurate description of the world as it really is? One popular philosophical idea is that we should prefer the theory with the fewest number of arbitrary assumptions, an idea known as Occam's razor, attributed to the friar William of Ockham, who lived from 1287 to 1347. Though this does not solve our dilemma. Many of the various interpretations of quantum mechanics each have approximately the same number of arbitrary assumptions. Therefore, in a situation such as this one, even Occam's razor can't help us determine which theory gives an accurate description of reality. Some people argue that asking whether or not a theory gives an accurate description of reality is not even a scientific question. They argue that the only question science can answer is whether or not a theory makes accurate predictions, since this is the only criteria of the scientific method. From this point of view, the only goal of science is to make more and more precise predictions, and not to describe the world as it really is. This is contrary to the views of many scientists throughout history who believed that they were, in fact, providing an accurate description of the world as it really is, and this is the entire reason they became interested in science in the first place. They might respond by asking, if science is not about describing the world as it really is, then what discipline do they need to sign up for in order to try to answer this question? After all, this is what they thought science is supposed to do. Much more information is available in the video titled Philosophy of Physics and in the video titled Quantum Physics, List of Philosophical Interpretations. Please subscribe for notifications when new videos are ready. And if you're able to, please consider supporting us on Patreon through the link in the video description. Thank you.